Hello and welcome back to Tech Talk. I'm Graham Hughes. Today we're going to be talking about PC power supplies, and we're going to be talking about it because basically I had my power supply fail, and I learned a couple of things along the way dealing with this failed power supply that I think would probably be helpful for a lot of people. So let me tell you the story about what happened to this power supply. This is a Corsair TX850M. I bought it just over 3 years ago, about 3.5 years ago. This was powering my gaming PC here in the basement, which is a Ryzen 5 3600 CPU and an AMD RX 5700 graphics card. I came down to do some gaming, fired up my computer, I was on Steam, I was just about to fire up my game and there's a loud crack! And my PC went dead. Now I knew it wasn't my power bar because my monitor was still on, my floor lamp was still on, everything else was still running except my PC had powered down completely. And in case you're wondering what it sounded like, it was a lot like when you flip the breaker on your home breaker panel. It has that kind of snap sound, but it was way louder. So it was this loud snap, and then the computer just died. Now with a power supply, they're a very sensitive piece of equipment for your computer, and there's a couple of things you have to take into consideration when this happens. When you think about it, the power supply takes the power from your wall, converts it to 12 volts, 5 volts, 3.3 volts, and then pushes it out to your computer. So your whole computer is relying on the quality and the consistency of electricity coming out of your power supply. So when you have a problem with your power supply, you want to think about carefully what steps you're going to take to make sure that you don't have any further damage to your computer. Because if you start getting bad voltages through the cabling and then into your components, you can start losing PC components. So in this case, I didn't try to start the computer again. It went black. I looked at the power bar is lit, my monitors are running, everything else in the power bar is working fine. So it is pretty obvious at that point that it's something wrong with the computer itself, it's not external. So I unplugged the computer, I took the power supply out of the computer, and what I always do when I have something like this is I take a whiff of the venting at the back. And so I put my nose up to it, took a whiff, and man, did it stink. It has a very distinct, when a power supply fails, it often has a very distinct burning chemical smell. It smells terrible. And this thing definitely had that. So it was, yeah, I'm pretty sure the power supply has gone away here. So I just happened to have a spare EVGA 550 watt power supply, which I put in the computer. I put it in the computer, started the computer. Computer runs fine. It's been running for like 2 months since this happened. No hiccups, no glitches, no crashes, nothing. So it appears that everything in the computer is fine and the problem was restricted directly to this power supply. Now, I have this dead power supply sitting on my shelf, and I'm the kind of guy, curiosity often gets the better of me. Don't ever open these, because the thing about these things is when you have them plugged in, they take power, and when they're unplugged, they have capacitors and other components in there that can retain that electrical power. So you can get a nasty shock from one of these even when it's not plugged into the wall. So anybody that makes this type of video is going to tell you, don't open your power supply and go monkeying around in there. That said, I was super curious what failed, so I went in and I monkeyed around. It's a really bad idea, but I was pretty careful. So I opened up my power supply. I took the fan out, I took the shrouding out just so I could see the circuits and the circuit board itself, and I could see if I could identify any failed components. I didn't touch anything, I stayed well away from it. And I used an insulated screwdriver so that, you know, if I did accidentally touch anything, I had a lesser chance of getting shocked. Having done that, I couldn't see anything inside that was amiss, so I reassembled it the way it was and tossed it back on the shelf. So rule number one is it's a very bad idea. Don't do what I did. Don't let curiosity get the better of you. You should probably just leave the thing alone. If it's not working, test it. If it's failed, toss it. The second mistake I made on doing that is when you open these up, there's little seals on the screws of your power supply. And basically those seals are there so that if ever you send this in for a warranty repair, they know if it's been monkeyed with or not. So of course, opening it up, I broke those seals. And I did that because I've owned this for over 3 years. I thought there's no way it's under warranty. Turns out on that score, I was wrong. These Corsair power supplies, they have 5-year warranties on them. So actually I could have sent this back and had it RMA'd and gotten a new power supply or had it repaired at least. I would have had to pay for shipping, but it's probably cheaper than buying a new power supply. So error number 2 is don't crack these open if there's any chance there's even a hint of warranty left on it. No, I'm not going to cry the blues about it. It was like $165 Canadian when I bought it. The shipping costs, you know, this being Canada, everything's expensive. Shipping costs would take a big chunk out of that anyway. So it's kind of neither here nor there. But here's the super interesting thing that happened with this particular power supply that likely would have made an RMA impossible anyway. So after this power supply failed, and I was thinking about doing this video, I thought I should probably get myself one of these inexpensive power supply testers off of Amazon. Now, these are just made in China, generic, no-name brand. It cost me, I think, $21 or $22 Canadian. They got all kinds of different connections for them. So they got like an 8-pin CPU connection, a 4-pin CPU connection, they got a 6-pin connection, they've got a SATA connector, they've got pretty much anything from your power supply you can plug into this thing and it'll test. And what you do, so in my computer I only had 2 connections. I had the 24-pin motherboard connection, I had the 8-pin CPU connection because all of my disk drives were M.2, they were right on the motherboard. So I took the 2 connections that were actually live in my PCO, but not including my video card connector because that's neither here nor there for the failure that I had. So I've taken my 24-pin connector, my CPU connector, you simply plug it into the ports on this thing, you plug in your power supply, and then you turn your power supply on. And when you do that, what happens is this connector sends a signal to send power, and it tells you what all the voltages are. And I was pretty surprised because when I did that, all my voltages coming out of this power supply are correct. I've got negative 12 volts, plus 12 volts, plus 5 volts, 3.3 volts. Everything's fine. And these power connector, or these power supply testers, if you do have an error, you get a beeping warning and the numbers will flash. And as you can hear, there's no beeping, there's no flashing numbers. It's telling me everything on this power supply is good. So you may be thinking, well, hey, go and put your power supply back in your computer. It's working fine. Here's why I'm not going to do that. I know that the problem that I had was a power supply issue because my power bar was working, my surge suppressor was working. Everything else attached to the power bar works. So it had to be a power supply failure, or at least a failure inside the computer. When I pulled the power supply out, I got that strong burning chemical smell that, by the way, I don't get now. And then when I put a new power supply in, my computer's worked fine ever since. So that tells me it was a power supply problem. So I know that there's an issue with this power supply. The fact that it's working today doesn't negate the fact that this thing still crashed on me once and had that horrible smell coming out of it. So I'm not going to put this back in a computer. This is going to go to recycling after this video is made, and here's why. Your entire PC depends on this thing doing its job and doing it correctly. Not giving too much volts, not giving too few volts, not running, having insufficient wattage to power your computer. If there is an issue in here, even if it's not today, if I plug it in today and whatever happened before happens again, it can cook the rest of my computer. It could fry my CPU, it could fry my memory, it could wreck a M.2 drive. So putting this back in my computer, I'd be saving myself the $165 cost of this power supply of replacing it, but I'm putting at risk my computer that I spent $1,600 to build. So even though this is giving me all the correct voltages now, and I know it's doing that, it's going in the garbage. I'm not risking it. So once you've decided to do that, for most people, you might not have a spare power supply sitting on your shelf like I do. The next thing is to decide, well, am I going to replace it? What am I going to replace my power supply with? So you'll note that I mentioned that this is an 850 watt power supply. The spare power supply I had was 550 watts, which is a big step down. You might be curious, well, how does that work? Because you've got a much smaller power supply in there now. And that comes to the next thing I wanted to talk about. When you go to change your power supply, you need to know what kind of power supply to get. Now, a lot of people just guess. They say, oh, well, I've got a high-end computer, I'm going to get myself a 1,000 watt power supply. But that's really not a good way to go about it. Because this is such an important component, you want a power supply that fits your PC. You want one that can provide enough wattage, and not just what your computer puts out, but has a little bit of headroom extra. You might be thinking about future proofing. You might want to have a little extra wattage because maybe down the road you want to buy a more powerful graphics card or add things to your PC that require more wattage. So it's really important to have an idea, how much power does my computer use, and given how much it uses, what kind of power supply do I need? Because the other side of that is you don't want to be wasting money. If your computer draws 350, 400 watts, you don't want to fork out big bucks for an 80 plus gold rated 1200 watt power supply. It doesn't make any sense. So you want to have that idea of how much power supply do I need. So that's what we're going to talk about next, is how to go about determining how much power my computer uses, and then what kind of power supply do I need. One of the best ways to determine what type of power supply to put in your PC is to use an online power supply calculator. Now I'm going to give you a warning about these. There's two different types of calculators. And there's all kinds of them, like Newegg has one, Cooler Master has one, PC Builds has one, there's all kinds of them out there. But there's two distinct varieties. One often comes from power supply manufacturers and companies that sell computer components. So what you do is you put all your stuff in and they'll say, oh, well, you should buy a 650 watt power supply. Or it might say, well, you should buy the Cooler Master RX 650, blah, 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 whatever it is. And those are okay, but you have to understand that what they're doing is they're taking the power that your system uses and they're recommending what they want to sell you. It may not be actually what you need. It may be simply what matches out of their inventory, what matches out of what they make. And it may not be the best deal or the most appropriate power supply for your computer. And as an example, I've put into some of these calculators configurations that I know take about 300 watts, and I've gotten recommendations for 650 or 700 or 750 watt power supplies, which is kind of crazy. Like, it's not reasonable. I want to know what my computer actually uses, and then I'll figure out what kind of power supply I want on top of that. If it wants to make a recommendation, great, but I want to know how much over and above my actual maximum use the power supply they're recommending is. So I recommend always using a power supply calculator that tells you exactly what that computer is going to use at max. So if you're gaming, if everything is running flat out, your hard drives are running flat out, your fans are running flat out, your CPU is running flat out, how much power is that computer going to draw at maximum? So my favorite power supply calculator that I use is at pcbuilds.com. And we're going to actually go through the pcbuilds.com power supply calculator. I'm going to quickly show you how to use it and show you why I like their recommendations and why I think they're so practical for most people. So let's go to their website. Let's take a look at how that website works. And then you have a better idea next time your power supply fails, exactly what kind of power supply you want to replace it with. Okay, so here we are on the pcbuilds.com website. We're going to take a look at how to use their calculator to determine what size power supply you need to replace one that's failed. So from the home screen, you simply go to Calculators and down to PSU Calculator. And the screen that comes up is the one that you're going to use to put in all the various components on your computer. Now it's important to remember you have to include absolutely everything. So that means LED lighting strips, keyboards, mouse, anything you plug into the USB ports, and you can kind of estimate it. Just if you're estimating, estimate on the high side. So let's start off putting in the configuration for my computer. So I've got an AMD Ryzen 5 3600. That's my processor. My graphics card is an AMD RX 5700 with 8 gigs of memory. The motherboard, there's not too many options here. We're just going to put in high-end desktop motherboard. I have 4 sticks of DDR4 memory, so we're going to put that in. For storage, I've got 2 M.2 drives, and that is it. I don't have any other hard drives. Cooling fans, I've got 120mm fans, and I've got, I believe, 3 of them. And don't forget these parts here, the input-output devices. This is for things like optical drives, Blu-ray, PCI Express cards. And then your peripherals are where you go into your USB connections. Now you don't have to get too detailed about this. For myself, I've got a standard plug-in mouse, I've got a gaming keyboard. And at any given time, if I think about other things I've got plugged into my USB, I might have 4 or 5 items plugged into my USB 3 ports. So let's go USB 3, and we're going to say 5 items, just to be kind of on the high end of things. So now we can simply go calculate PSU wattage, and this is the part I love about this website. It gives you 2 pieces of information. So when we look at the top here, it says Power Supply Calculator Result, Thermal Design Power by Components. So as you can see, it goes all the way down here and gives you the wattage for each component I've put into the calculator. So my processor is a 65 watt processor. My graphics card is a 180 watt graphics card. My motherboard can be expected to use 70 watts. My memory 24 watts because it's 6 watts per module times 4 modules. So all the way down it tells me about how much power my computer is using. At the bottom it says total configuration wattage is 381 watts. So what that represents is the maximum amount of power my computer would be likely to use if everything was plugged in and I'm, say, gaming and everything's running at full tilt. So all my fans are at 100%, my CPU is 100%, my graphics card's 100%, everything's going great guns. That's about how much, worst case scenario, my computer is going to use. Now the next section on this site I really like. It says recommended power supply wattage. So it tells me in the first paragraph that my computer has a TDP, a thermal design power, of 380 watts, or 381 watts. Then it says essential power supply threshold, sustaining performance. Now we know that you don't want to buy a 380 watt power supply because it'll be running at 100% often, and then you run the risk of getting bad voltages, it'll be running hot, the fan will be loud, and it won't last as long as a power supply that has a little bit of headroom, a bit of extra room in the wattage, so it's not constantly running at its maximum capacity. So here it's saying the minimum power supply wattage required for this setup is 475 watts. So even though the computer only will use 381, worst case scenario, to be a comfortable fit, at a bare minimum you want a 475 watt power supply. Now the next paragraph is recommendation for enhanced reliability. So again, we don't want to be stressing that power supply out. The higher wattage consideration, it is strongly recommended to invest in a power supply with a wattage of 550 watts or more. As luck would have it, the spare power supply I had on my shelf was exactly 550 watts, and that's what's in that computer now. So using this calculator, I can say that the power supply I put in, even though it's a lot lower than that 850 watt power supply that I had, it's still an excellent power supply for this computer. Now the reason I had bought that 850 watt power supply was I figured at some point I'm going to want to upgrade my graphics card, and that's still a plan that I have. At that point I'll come back to this calculator and I'll check and see if the new graphics card is going to be sustainable on 550 watts. If not, I'll have to replace the graphics card and the power supply together. So that's pretty much everything you need to know about failing power supplies and how to go about getting a replacement. I hope you found this helpful. Again, I'm Graham Hughes. This is TechTalk.net. Feel free to leave your comments down below, and I'll see you on the next video.